Welcome to the Improving Webinar series where our improvers share the knowledge. If during this presentation you have any question, you can ask via the Q&A feature and I'll pass it on to the speaker. Today, Sergey Vershin, who has over 2 decades of experience in a variety of roles across multiple verticals, including government, media, agriculture, healthcare, retail, and education. His expertise spans solution architect, artificial intelligence, machine learning, and statistical data analysis, cloud infrastructure, cybersecurity, product management, and business strategy. For the last 3 years, Sergey has been leading Improving Google practice, overseeing the design and delivery of projects, leveraging products and services on the Google Cloud platform. Outside of work, Sergey is currently training for a 5 kilometers race this fall and planning a downhill skiing trip to Japan. Today, Sergey will walk us through Google's cutting-edge tools and infrastructure and how it makes high-performance computing, artificial intelligence, and machine learning easier than ever. Without any further ado, Sergey, you can take it away.
Perfect. Thank you, Sergio, for the introduction. Hi, everybody, and welcome. So today we'll go over the interesting topic of high-performance computing on the Google Cloud platform. Broadly speaking, we're going to have a brief overview of what improving is about, and then head on to the main event, which is HPC on the Google Cloud platform. And then talk a little bit about the Scientific Computing Portal, which is a solution that Improving has developed for this space. So, a quick overview of Improving. We are a global technology services company focused largely in North America, although we do have a growing presence in Latin America, as well as we had recently acquired a company in Pune, India. In terms of the services that we provide on the Google Cloud platform, it really spans the full gamut, starting with landing zones for regulated industries, be it government or finance, where you need to make sure that you adhere to security compliance standard, as well as all manner of modernization, so migrating your infrastructure or your application loads and databases, data warehouses to the cloud. We also provide data analytics and AI/ML solutions. And last but not least, we also do staffing. Noteworthy, a couple of years back, we were awarded Partner of the Year Public Sector Canada in 2023 by Google and are looking forward to applying and hopefully getting it this year as well. Now, in terms of the types of companies that we work with, again, there is a strong focus on public sector in Canada. However, it sort of spans the gamut, and you can probably see some familiar logos in there. Anyway, so with that over, I'll move on to the main event, which is really high-performance computing on the Google Cloud platform. And before we get into the Google Cloud piece of it, really it's worth talking about why do HPC in the cloud? And like, what is HPC? Well, HPC is essentially large volumes of compute that are basically a requirement these days in doing science. We generate a lot of data. To process all of that data, we need a lot of compute. Supercomputers on premises are not a new thing, but there are certain advantages to doing this in the cloud. So first of all, it's the capital model. If you're building your own HPC cluster, there is a large upfront cost. We're talking in the millions, if not tens of millions of dollars for a sizable cluster. So capital expenditure upfront also implies costs of maintenance and staff and other such things. In the cloud, this is not a capital expenditure, it's an operating cost. So it's a lot easier to plan around. The scalability is also worth noting in that on premises, what you've built is what you've got. Whereas in the cloud, it is elastic and you are able to right size it for a given day, week, given workload. So there's a lot more flexibility there. In terms of hardware, again, with on-prem, you've got your procurement and maintenance life cycles, but ultimately, when you make the choice to purchase certain hardware, this is what you've got. We all know that technology sector and technology moves rather quickly, and new CPUs, GPUs are released annually, sometimes more often. So if you want to have access to latest and greatest, it's just not practically possible with an on-premises setup. With the cloud, you always have on-demand access to whatever it is that you need, and it is managed for you. So you don't need to have staff essentially looking after the actual instances. They're there for you, taken care of by the cloud services provider. Ultimately, this results in time to science being shorter. It's faster to get researchers, engineers using these sort of high performance compute clusters a lot faster. There is no wait lists. You don't redline. If you need it, it's there for you. And ultimately, as I've mentioned, the cloud offers a lot more flexibility than an on-premises setup. Now, why do it on Google Cloud? So there is a number of reasons. Every cloud will tout their advantages, but I do honestly believe that the Google Cloud formula is the best offering available. Namely, purpose-built infrastructure. So Google's cloud is like Amazon's and Azure's, very large. And with that scale comes access to the latest and greatest in hardware. We're talking the H4C instances with the AMD EPYC chips. You've got low latency networking, including cloud RDMA, which is the remote direct memory access technology, all kinds of parallel storage systems that I'll mention later. In addition to just the latest and greatest hardware, you also have access to market-leading AI/ML integration. So the one thing that Google Cloud offers that is in the Gartner's sort of top right, full-featured and most mature is their Vertex AI ecosystem. And that makes it very easy to take the data that you've processed using HPC and then bring it into your AML, either research and development, training, etc. Now, also with that, aside from the AI/ML ecosystem, there's also the data analytics ecosystem. BigQuery is market-leading data warehouse in the cloud, and all of the data engineering and data analytics goodies that the Google Cloud offers are also available. Finally, it's worth noting a couple of other things, such as the commitment to open source. So Kubernetes, which we will discuss at some length today, was a Google project that Google donated to the world and remains one of the main contributors. Similarly, the Google Cloud Platform embraces open source and is very much interoperable with the open source technologies, be it ones that Google themselves offer or that are just available. And finally, this is also, I think, very much worth noting, is sustainable cloud. So Google's record for running data centers on carbon-free energy is excellent. So I'm in Canada, and the Montreal region is 100% renewable. I know that Europe North 2 out of Stockholm is also 100% renewable energy. Most of the regions are above 90%, and I know that US Central 1 in Iowa, which is the biggest region that Google has, is 95% carbon-free energy. So if you're looking to not just do good science, but also save the planet or help to, push back climate change, then sustainable cloud is the way to go. All right. Now, how can you do HPC on the Google Cloud? There are three main ways, really. It's you either use virtual machines, which is sort of the old school way. You're mimicking what the on-premises setup is, using Google Compute Engine, or you go with the Kubernetes option, which is the Google Kubernetes Engine is the managed service offering of Kubernetes on the Google Cloud Platform. And it is the most mature Kubernetes offering out of all of the clouds, partially because Google invented Kubernetes. As an example, a Kubernetes cluster on GKE can have up to 15,000 nodes, which is about 3 times as much as Amazon allows you to have. Finally, there's Google Batch, which is a fully managed compute service for large scale jobs. It allows you to just bypass all of the infrastructure concerns and get straight to crunching your data. Now, we're going to go over each one. So, why would you want to do HPC on virtual machines? It's traditional HPC applications are typically mapped this way. So, if you have an on-premises setup, you might be running on VMware or it's actually on bare metal. But you're essentially looking at Slurm usually, which is a HPC scheduler technology, where each one of your nodes, the workloads that run on each one of your nodes, will have fine-grained access to the operating system. And essentially, it's kind of the traditional way of doing it. So there's very little change from traditional HPC approaches. Now, key features for HPC with virtual machines is really HPC optimized virtual machine families. As I'd mentioned, Google has a number of these. So there's the H4Ds, which are the AMD Turin architecture, H3 with Intel Sapphire Rapids. There's all manner of like A3s have NVIDIA H100 GPUs. There's also high bandwidth networking. So Google's global network offers up to 200 gigabits per second. And also there's the option of cloud remote direct memory access, which is a technology that works very well with MPI, which is the message passing interface. So that's typically used for optimization of workloads on Slurm. And finally, parallel file systems. So much like on-premises, you would have something like InfiniBand. I'm sorry, InfiniBand is the networking technology. Lustre, I think, is the one that I was thinking of. Parallel store, file store, there's a number of hardly parallelized storage technologies that are available on Google Cloud if you need very high performance storage. You're moving a lot of data around. So basically, there's a very healthy selection of the latest and greatest in terms of underlying custom machine types. And the VM approach is most closely matched to what you would see on premises. Now, with Kubernetes, you are looking at workflows that are set up from the get-go to use containerization. Perhaps you have some microservices-based HPC applications. You require dynamic scaling and integration of CI/CD. Essentially, when we're talking about HPC, Slurm, which I've mentioned a number of times, so it's a scheduling technology that's used on about half of the world's top 50 supercomputers, and it has its heritage in Linux and standalone systems. That is the technology stack that's been used by researchers for a very long time. The Kubernetes approach is something that has evolved out of the more business-oriented sphere and is very popular with AI/ML training. Originally, Kubernetes was really designed for web applications, but it very quickly became clear that there's many more usages for container orchestration and the fault tolerance and the just orchestration features that Kubernetes offers. Now, as far as on the cloud, key features of HPC here for HPC include the same instances. So you have access to the GPUs and the processor architectures that I've mentioned previously. There is Q with a K, which is a system that provides job orchestration similar to what Slurm does, although Slurm doesn't benefit from the Kubernetes orchestration capabilities. So Q's feature set is a little smaller because Kubernetes takes care of some of the concerns around scaling jobs efficiently and scheduling them. Now, the other thing that is useful with Kubernetes is the integration with a variety of other services on the cloud. Kubernetes itself is a managed service, and it is like all services offered on the Google Cloud Platform is tightly integrated with a variety of other services such as logging, monitoring, and access to all the storage technologies. The other thing that I actually forgot to mention is the ability of, this applies to VMs as well, is on the Google Cloud, you can place them in a way that ensures that the actual physical machines are close to each other, which reduces latency. This may or may not be as applicable with Kubernetes because the focus really is more on fault tolerance rather than kind of maximizing latency. And I'll go over the differences later in the presentation. Now, if you are in a situation where you really don't have the expertise to lean on for infrastructure management, there is the Google Batch option. It works really well with workloads that can be parallelized to a great degree. And it's really a SaaSified version of HPC that allows you to just bring your container or your script and point to the data source and press go. There's minimal configuration. You can use spot instances to control your cost. And otherwise, it's, again, very tightly integrated with all the services such as cloud storage, logging, monitoring, etc. And it really automates and takes away all the complexity. So where with VMs, you're looking at something like Slurm or Altair, which are sort of traditional on-premises HPC schedulers, and how to set all of that up. With Kubernetes, it's even potentially more complex because it's not as mature an ecosystem for HPC, but it does offer even more flexibility. So you got lots of power, but you have to take on a lot more tasks. Managing Kubernetes cluster is not the faint of heart. For any who are in the audience and have tried it, I'm sure you know what I'm talking about. Google Batch takes all of that away. It's essentially an easy to use UI where you upload your script, you figure out what you want as far as your budget, and you click go. Now, I talked about a fair bit of complexity, the fact that even with the training that is provided for the Google Cloud Platform and other clouds as well, ultimately it's complicated. There's a lot of access control, networking, a lot of infrastructure considerations. What Google has done is actually created a wonderful piece of kit called the Google Cluster Toolkit, which is an open source project that's been around for quite some time now. It used to be called the Cloud HPC Toolkit. And what it does is it allows you to, in about 40 lines, well, I guess it depends, but in a YAML, essentially, specify what kind of cluster you would like, what sort of nodes in that cluster you would like. Do you want one partition or two? And essentially feed that into a program that will generate a very sophisticated Terraform script that is probably around 3,000 lines that you can then apply in a infrastructure as code manner to essentially provision all of your cluster automatically. And it's extremely customizable, extensible, and there is a wonderful community of users that are very active on the GitHub. I've seen the presentations by the team at many of the Google Cloud events. And in addition to officially supported technologies, which I believe are Slurm, GKE, and batch, the Google Cluster Toolkit also supports community plugins, essentially, for third-party schedulers such as Altair. It really is a lifesaver, and the difference with the cloud approach, of course, is typically on premises, you would have the hardware and the Slurm coordinator kind of knows where the machines are. The cloud version only needs, in the Slurm's case, a couple of nodes, a login node and a coordinator node. The login node can be very small because it literally just provides a shell that for a user to execute commands, but it doesn't actually do any of the work. Coordinator node manages storage, so it does need to be a bit beefier. But the wonderful thing is the actual nodes of the cluster scale on demand. So you launch the job, and that triggers automatic provisioning of the VMs, and the cluster toolkit provides excellent middleware to enable Slurm to operate on the cloud. All right. So some additional considerations around why would you choose one over another. Slurm is ultimately best for fixed-sized deployments because that makes it easiest to plan around capacity and cost. And one other thing to consider is essentially how you're paying for this. I'll mention it a bit more in the last bullet point. Now, Kubernetes is ideal to be the foundation for a more dynamic setup where, some days you require a lot more compute than others, and the loads are varied, and you have a complex multi-step workflow that involves other technologies, and maybe there's some microservices that are at play as well. So if you're living in the very complicated world, Kubernetes might be the way to go. I've seen, so mostly the work that we've done has been with companies in the bioinformatics space. And I've seen sort of more established institutes, research institutes, they lean towards kind of more traditional approaches. So they're either on commercial schedulers or are moving to or using Slurm. But I have also worked with some biotech, I guess drug research companies that were operating on Kubernetes. And similarly, I believe one of the research partners of the Research Institute, they were in Europe and their infrastructure was Kubernetes based. So really, it's sort of, whereas before it used to be fairly clear cut, you have your traditional kind of supercomputer nerds and they tend to go for VM approach and fixed size clusters, and you had the newfangled AI/ML crowd who leveraged Kubernetes for model training. I think these days there's quite a lot of overlap. Checkpointing is something that's very important, essentially for complex multi-step workflows. You want to be able to save your work in the middle of it, maybe a number of times. Slurm makes it a bit easier to do because there's primitives in the system, such as scripts, jobs, child processes, and you're not dealing with containers. And there are plugins that allow checkpointing using traditional Slurm workflows. With Kubernetes, it's sort of ultimate flexibility, as I had mentioned. There are approaches to do this. You can sort of save state of containers and put them into storage and spin them up again. Ultimately, I think the checkpointing is not an easy thing to implement. The Slurm solutions tend to be more mature, but you can certainly do it on Kubernetes as well. And with containers and runtimes, ultimately Slurm is VM based, and you can call containers, but it's not a natively container aware system. So if your workloads are container oriented or the workflows prefer containers, then Kubernetes is probably the more natural path to take that comes with all the versioning and optimization that containers allow. Now, things that are very important to consider in addition to kind of what the technology can offer, because I've spoken about Slurm and Kubernetes as kind of the two paths, but I don't think you'd be surprised to hear that there are people trying to run Slurm on Kubernetes, and I've seen at least a couple of projects that currently allow you to do that, although it's limited in its functionality and features. But ultimately, so technology is what it is, and it will continue to advance. The team that you're dealing with is really something that's important to consider. And here it's, if you're choosing one path over another, do you have the people in your organization who will support your journey, whatever technology stack you choose? And if you don't, do you have the budget to hire them? Are you going to provide them the training? The cloud does solve some of this, but I think to be realistic, unless you're doing something like Google Batch, where it literally is point and click, you will still need some support. And it does shift from having people who are used to dealing with physical servers to more of the cloud architect, cloud engineer type roles. But ultimately, the team skills are a very important consideration for when you're choosing how to kick off your cloud HPC journey. And I mentioned budget. So the cloud does offer the ultimate flexibility. You pay for what you use, but it's pretty common for clients to feel, especially in an HPC context, because you can easily spend, tens, hundreds, millions of dollars running jobs. It's like, well, how do we control this? And now, depending on the type of institution that you're coming from, I do know that Google offers a subscription agreement model, which allows you to cap your spending. This is offered to governments and public sector institutions for the obvious reason that those types of organizations typically have less flexibility with how they use their funding. And so the subscription model works really well with something like Slurm, because what you can do is, if you're kind of migrating to the cloud from an on-premises environment, you can model fairly closely what the on-premises environment equivalent would look like in the cloud in terms of the number of VMs you would be using and how big your workloads are and how long it would take to crunch through them. So it's a lot easier to right size a Slurm-based setup. And then if you are confident in terms of the resources that you will need, then you can further kind of assure yourself and your management usually that you'll be able to fit within the budget envelope by having a subscription agreement in place. Now, when it comes to something like Kubernetes, right sizing is and predicting how much it's going to cost is kind of a more involved undertaking, namely because it's more dynamic. That being said, Google offers a variety of tools to deal with this, and there are third-party tools, including our own, that allow for this. Essentially, it's always a good idea to measure everything that you do and do your best to kind of have a clear idea of the compute resource needs that the organization has by monitoring what's actually happening. There are budgets that can be set on projects and alerts that will go off when you're sort of at whatever intervals, in 25, 50, 90, 95%, so that you'll have visibility on how much money is going out the door. But ultimately, the budget model and flexibility around spend is something that also works into the choice of technology. Now, one thing I wanted to show that's kind of neat, it's a graphic of the scaling up of a Kubernetes-based HPC cluster. and they got up to 855,000 virtual CPUs, 53,000 instances. At its peak, this was the top 24th supercomputer in the world. If you look at not hypothetical, if you look at the actual sort of architecture maximums, if you were to max out what Google Cloud offers, you can actually, now this is about, the information is a couple of years old, so I'm sure there's bigger supercomputers now. But at the time, it was the seventh largest supercomputer in the world by sort of compute capacity. So if you've got the money, Google's got the hardware to do your compute. And it's, I remember showing this graphic at a workshop that I gave on the same topic. And the next question was like, well, how much did that cost? Now, I don't know. I'm sure it wasn't cheap. But at the same time, if you're in the business of high performance computing, there's a reason and there's value behind what you're doing. So, but as far as capability goes, it's more than possible to get all the compute you'd want on the Google Cloud. All right. So last but not least, I mentioned some sort of challenges that inevitably organizations have around moving into the cloud and controlling budgets, etc. In our work with a previous government client, had developed a solution that we call the Cloud Computing Portal that is targeting a lot of these pain points. Essentially, it's a cloud native application that allows engineers and scientists to easily request and provision the resources, whether they know or not how to do Terraform and infrastructure as code, and whether they know anything about, how to set up a Slurm cluster with the toolkit or without, or Kubernetes, etc. The other user type for the solution is managers who actually get a chance to review the resources that are being asked for and approve them, and as a result, have visibility on expenditures. And finally, there's the admin role, which essentially has to do with inviting users, controlling access, and providing support, such as increasing quotas. If you've ever worked in the cloud with sort of large numbers of compute, you do very quickly hit the initial quotas that are allotted and have to kind of interact with Google Cloud Administration to raise those quotas. This is pretty rational, sort of a trust building exercise, because typically people who spin up hundreds of thousands of instances don't come out of the blue. And usually the cloud providers, it's not just Google, want to have some visibility on how that capacity is rolled out and made available. Now, the portal essentially allows single-click provisioning of a variety of environments. We've got the Slurm-based HPC, Vertex AI Jupyter notebooks in a few different flavors, whether it's sort of your standalone VM that you fully control, or there's a couple of flavors that Google has, Jupyter environments that are managed. Simpler things like VMs with cloud storage. There's a couple of genomic workflows that are also available. These are more like samples and an Earth Engine template project. Essentially, what we did was use the cluster toolkit and another open source project that Google has called Rad Labs, and integrated those into the application as sample environments that can be made available. The system is built with a modular architecture, so it's very easy to add additional environments. So if there is a specific type of HPC deployment that you're thinking of or making available to your researchers, we can certainly put that together. And last but not least, security by design. So we are the initial client for this leveraged, the initial client for this was for government, and they had some fairly stringent security requirements. The system is designed to operate in what the Canadian model calls protected B, but essentially it's secure enough to the NIST 853 standard. You've got endpoint security, using identity-aware proxy and the least privilege access control model throughout. So I wanted to demo, but unfortunately, I will have to restrict myself to a video. You log into a very easy to use UI. It has English and French. And this is the administrator view where you can add users, invite them, give them a role, invitation management capabilities available as well. And each each scientist user has a manager assigned, and you can do transfers, etc. It will send email, and we have the system able to use a variety of email services, including a do-it-yourself SMTP server if there's no interest in using it. So here we've got an HPC cluster configuration being selected. There's a variety of different options. You essentially have the ability to select the type of storage, the size of the compute partition, the type of instances. It will actually pre-calculate the amount of money that it'll cost to run these on the assumption that they're running 24/7, which isn't the case with Slurm unless you're actually running workloads on it. In addition to this, there is the project management components, which essentially require the requester to point out, when do you want to start? When are you going to finish? And it'll provide a bunch of warnings around, it's like, well, you're requesting something that could potentially cost, $2 million. So the budget you're requesting isn't covering it. Essentially, all of this gets put together and submitted for approval by a manager. So instead of just having users willy-nilly spin up whatever, you have the ability to have some oversight. So a manager user will receive an email notification, and they essentially get to review what's being requested. So the researcher sees that it's been approved, and all they have to do is click start. So this system really is about frictionless access to the resources. So this kicks off a fairly sophisticated chain of pipelines in the back using Terraform, where all of the information that was input by the user around their preferences gets put into a Terraform script. But ultimately, you end up with very easy to access links that essentially bring you right into your Slurm cluster. And here you can get to science. With this, I'll wrap, and thank you very much for attending. And if you're interested in potentially exploring HPC on the Google Cloud Platform, then I would love to hear from you.
Awesome. Thanks for the presentation. We have a couple questions, Sergey, from the audience.
Okay.
First one goes, the shift from CapEx to an OpEx model is clear, but how do you recommend we effectively forecast and control costs with an elastic on-demand nature of the cloud?
Ultimately, it depends on kind of the technology that you choose. If you're doing a VM-based tech stack, then it's easier to predict sort of what your compute would be. And again, it also depends on where you are in your kind of journey. Are you looking to burst or onto the cloud, or are you looking to move completely? But ultimately, I think with Slurm, it's easier because it mirrors the on-premises setup more closely. And if you are a public sector organization, you have the ability to actually cap your expenditures using a subscription agreement model. Which is, I believe, is unique with Google, actually. They're the only cloud provider that offers this sort of, like, you could run over what you said you'd use, and you still only pay for what you've contracted. But then on the Kubernetes side, it's really around wrapping your head around, well, what are you actually using, and trying to model um, your demand. One thing that I haven't really gone into is preemptive VMs. So you can actually leverage preemptive VMs, which can be very cheap, like over 50% cheaper than regular instances. Now, this can be used for Kubernetes clusters as well. Essentially, a preemptible VM is one that I think it's only guaranteed for 24 hours, and then it will get yanked at some point in time. So introduces a measure of sort of unpredictability, but you can actually architect for that. And one of the benefits of Kubernetes is the system itself is designed to be fault tolerant. So you can actually have a node in a Kubernetes cluster go down, and Kubernetes itself, with the built-in sort of capabilities, will it'll move the pods and it will make sure that the workload continues. That being said, of course, complexity doesn't come without cost, so you will need to architect for that, especially if you're talking about, the preemptible VMs don't mix very well with long-running processes. So if you've got a kind of workflow that is very parallelized and the chunks are small, then using preemptible VMs works. You save a ton of money, and the nature of your workloads allows for it. But if you've got something that has to sit there and run for a month, the last thing you want is VM dying on you in, the last hour. It's a lot of wasted compute. So essentially, know your workloads, measure your usage, use budget alerts, and as I showed, some solutions like improving Portal can actually help as well to manage the costs, because the one thing that we'll do is the reason for setting the budget is not just alerts, but the portal will literally kill a project, or at least freeze it once it's past its budget. Um, Now, again, you have to be, there's an interplay there between what kind of workloads are you running? Do you want to be shut down in the middle of it? But essentially, there is tooling out there to make financing all of this more predictable.
Awesome. Thanks. I think we have 10 minutes for one more question. It goes, the presentation notes that Slurm is ideal for fixed size loads, while Kubernetes is better for dynamic loads. Could you expand on the practical trade-offs, especially regarding checkpointing and container support?
Slurm wasn't designed with containers in mind. So if containers are your thing, then Slurm is not the best option. Um, However, if you are coming from kind of a more traditional HPC environment and your application workloads use MPI, then yeah, it's essentially kind of boils down to where are you coming from and what kind of workloads are you using. I think Kubernetes world tends to there's overhead. There's a practical overhead. Slurm clusters, once set up, they pretty much they're the cluster toolkit makes it almost too easy to set one up. Kubernetes, you do have autopilot, and it is possible to set up a Kubernetes cluster while using cluster toolkit as well. But typically, it's been my experience that you want some staff on the team who understand how Kubernetes works and are able to administer it. And you quickly get into things like service meshes and API gateways, and the networking is more complex. So really, I think I like to think of Slurm as a kind of a more tried and true path. And if you are in the world of on-prem HPC um, in a traditional way, then Slurm is possibly the technology you're already using, so it's the easy choice. Kubernetes is really like you have a very complex workflow, and you need um, the most flexibility that you can find. So yeah, and ultimately you can use containers with Slurm workloads as well. It's just that they are not natively supported. So some of the safeguards and guardrails that Slurm provides will not be effective if you're using containerized workloads with the Slurm scheduler. That's it.
Awesome. Thanks for the presentation, Sergey. It was really informative and entertaining. Thanks everyone for joining us today. And remember that next week on July 30th, our colleague and president of Improvement Ohio, Josh Harrison, will be presenting From Cloud to Omnichannel Full Stack Modernization Case Study. You have the link in the chat, or you can find it on our internet portal. Thanks again, everyone, for attending, and see you next session.